Welcome to the very last session on the very last day of Build. Thank you for all of you for coming. You do get the reward for the absolute best attendees at Build this week. Of course, you don't get money or gifts, but I'm sure that accolade makes you feel good inside. My name is Mark Souza. I'm a general manager for the Cloud and Enterprise Engineering team back in Redmond, Washington. I run a team called the Azure CAT team, Customer Advisory Team. We go out and we work side by side with you building large, high scalable, high availability systems on Azure. And with me today is Agal.
Hello, my name is Agal, and I'm a principal PM manager in Azure Engineering. I own Azure VM availability, scalability, performance. And with us today is Hongfei.
Hello, I'm Hongfei. I'm so glad to see so many of you showed up. You're resilient enough. I'm a database person at heart. I went to Wisconsin, got my PhD there in database systems. It's the university where our CEO, Satya, actually went to too. Go Badger. Then after I graduated, I worked in SQL Server and Engine for about 10 years. Now I'm in Azure, leading a team that's responsible for Azure resiliency across all the services. If you're interested in knowing what we do to improve our own service resiliency, or if you have feedback to us on how we can help you to improve your application resiliency, come talk to us after the talk. So today, we have only one goal, which is to deliver a successful and resilient session for you. You deserve it. To do that, I'm a database person, right? What do we do about resiliency? To me, resiliency is about data availability. For this, I'm paranoid about backup and replication. For this presentation, we made 3 copies of our presenters. We also have backup. In case there's a crash, let's roll back. What's it?
Let's get high.
No. It's a wrong state. Igal, I think you're still at yesterday's party.
Oh, yeah.
So application consistency is important for recovery. Now, please roll back to the right state.
Let's
get
started.
Okay. Thanks for letting us get a little silly with you. We appreciate that. Of course, weed is legal in Washington, so they don't get this joke. So today, we're going to tell you a story. It's a real customer story. It's a very successful online retailer that targets the 20 and 30-year-olds. And it's a very cool, fun, and rich experience for them. And they grew up from a startup to very, very successful. Think about this image for a second. You log on their site, and on the left-hand panel, there's a bunch of specifications. On the right-hand panel, it's a very rich, dynamic content. And you just click on things like, maybe I want boots, and bam, up comes all the boots. And wow, that's overwhelming. I don't know what kind, but maybe I want it to be black. And boom, here's all these black boots. And maybe I pick a kind, and it keeps going and going and going. It's a very dynamic, rich experience for these young folks. Anytime they want, they can do a 360 view of the product. And when they get down to the final product, they'll even see a model wearing those apparel or accessories. So it's fun, and it's very popular. Like most startups, though, when you get popular very quickly, what happens? Scalability. Uh-oh, I have to re-architect my solution to handle the new workload coming. And when I have to re-architect, I think about, maybe I need a new platform. I can at least look at a new platform as well. And there's 2 criteria they need. Obviously, scale, because the customers are coming, they're very popular. And the other is resiliency or high availability. Now, for scale, it's a 24/7 online retailer. So you can imagine that 3 o'clock in the morning, there's less transactions than popular shopping times during the day. Or worse, how about a Black Friday? 15 to 20% of the entire year's transactions are done on that one day. So you can see the difference in the elasticity of the application. Therefore, the cloud, in this case, Azure, was a perfect place to put this application. But it has to be resilient. And that's our story today. We're going to take you through the story of what they did as they re-architected and moved to the cloud. Now, you ever see a movie where the beginning of the movie is actually the end of the movie, and then they go back and take you through? Well, that's what my story is. I'm going to start with the ending. Here is the application running in the cloud. Let me take you through the functions of this application. The front end is the customer experience, what I just described. All right? And the back end is where all the state processing is done. Shopping cart data, inventory, distribution, all the data is being updated and manufactured in the back end. And of course, that's in the Microsoft Cloud, Azure. So I walk through the components. There's the user experience. Obviously, it's a mobile device, PC. They get that fun experience, and that content comes from Akamai, a very close partner of Microsoft in the content management in the routing space. But Akamai plays that role, and they're sitting in an edge cloud. Now, when they need to actually purchase something, or they want to open up a shopping cart, in this country they call it a bag, but let's call it a shopping cart, they actually call Traffic Manager. Think of this as a global service, DNS service from Microsoft that grabs a DNS name, it goes to a region and brings back an IP address, and that IP address Akamai will use to make the direct connection into that region. When you get in the region, there's obviously a load balancer, because behind the load balancer is a bunch of VMs that are stateless. This is where the business logic is being done. So that's obviously a scaled out situation. The business logic now needs to manipulate data, read, write. And what do we do for that? We go to our SQL database, where we get a read, write. Of course, we want the performance to be so good, so what do? In front of that, we put a cache. This looks very familiar to many of you that built these types of applications. We put a cache, and in this case, it's a platform as a service Redis solution. So you can see the combination here of platform as a service, infrastructure as a service put together. And below that, if you look below that line, you see Elasticsearch and Kibana running on Linux in a VM configuration where we collect telemetry. Your typical cloud app constantly collects telemetry. For, in this case, 2 reasons. One, for health of the system. I want to make sure it's always healthy. I'm collecting telemetry, I'm monitoring it real time, making sure all the components are working. And the latency is what I want my customers to experience. Also, we can monitor customer experiences. Think about, they're spending a lot of time in this section of my website. Maybe I can go improve things as well. So this is the application running in production today. So let's put resiliency to this application. Okay, so you can see, just got a little busier. All I did is take the application I showed you, and I put it across regions. Region 1, in this case, is Northern Europe, and Region 2 is Western Europe. So I have my application across these regions. Now Traffic Manager actually is doing its job. It will send us to the right region. And the way it does that, it's rule-based. You can make it performance-based or round-robin. In this case, we picked mode, performance mode, so it sends you to the quickest region, or maybe the closest region in this case. The middle tier, the stateless set of servers, I'll talk about resiliency throughout the presentation, but the hard part is obviously the back end. When you go across regions, you have to worry about the data, and the data has to be across the regions, and it has to be kept in sync. And in this case, I'll just explain what happens business-wise, because it's a very resilient app. They come in, and I get my shopping cart. I get sent to a region, and that region has a primary SQL database. That's the first SQL database that you see. And then it replicates, using technology from Microsoft, SQL Server, we'll talk about later, it replicates a read-only copy to the other region. And then what happens is, if a shopping cart goes down for 1 minute, I'm going to lose that customer. So they designed this to say, right inside the application, hey, I'm going to go to my primary, and then if I don't get to that primary, I'm going to go to that secondary, and I'm going to grab my read-only copy of that. In this case, it's asynchronous copy, and I'm going to bring that in and make that my primary. Now, since it's asynchronous, I could lose an item from the shopping cart. It is potential, but losing an item is a lot better than losing my shopping cart. So that's kind of how they do that. So that's the end of the story, a very successful situation. Now, as I take you through this journey, you might be saying to yourself, hey, I'm not a retailer. Why is this applicable to me? I'm just a bunch of good developers that build stuff, and retail is not one of them. Actually, it is applicable to all of us. There are patents here that will be applicable to us. The most obvious one is dev test, a single instance where I actually build things, and then I have to determine how to deploy it. Maybe you use multiple VMs in your development, or a more sophisticated multi-VM situation with state or with data in the back end. So these patterns will be covered today, so it is applicable to many of us. So we're going to show you how to build it, deploy it, and just as importantly, maintain it. Resiliency is true end-to-end. You have to think about all these things as you go through building a resilient application. It's going to be infrastructure heavy. I know we're developers. We'll show you some snippets of code. We'll show you architecture where we combine PaaS, we combine IaaS. But 90% of the deployments on Azure today, even the robust mission-critical ones, has infrastructure components in it. So I think it's very important to spend time on that today. Well, let's start our journey. Here's our picture. It's in our head. Some overpaid architect drew it on a whiteboard. Now we as developers have to go build it, figure out if they're right or not. And what do? Well, obviously, we'll go to the cloud, and we'll do our development. Maybe we'll bring up a single instance VM. All right, and then we'll start developing. We start developing the web, put our business logic in there, maybe our database logic in there. We figure out what services work, what services don't work. And we figure out, okay, I'm happy, I know what to do. Now I have to deploy it. And this customer, they're large. They're going to deploy it to many, many VMs and highly resilient. But you might decide, maybe I just want a single instance. What do you get from a single instance as far as resiliency goes? Not much. Of course, Microsoft's going to do our job. We're going to try to keep your VM up all the time. But it's not going to be up all the time. You have to update your app. Hardware, once in a while, it might have goes down or breaks. There are cases where it will go down. So what are you going to do for a single instance? Well, you can use Azure Backup. So Hung Fei, will you come talk to us about this?
Sure, thanks, Mark. So, as Mark said, we live in, unfortunately, imperfect world, right? Bad things happen. Hardware can fail. A misconfiguration can lead to performance degradation. Does it happen? Did it happen to any of you before? I guess this is lucky folks. Nothing happened to you. Somebody might unintentionally drop your most important database. What would you do in those situations? You want to back up. You want to replicate, right? So here's what you do. You want to replicate your stuff. You want to back up your stuff such that when bad things happen, you can fast recover. What is the goal here if you are in this imperfect world? You want to minimize your downtime, right? You want to minimize the downtime to your customer and to your business. So the challenge here, though, is application level consistency. It's not so easy to keep all the state in consistent state such that the recovery can be fast. Azure Backup is a very great tool to help you to achieve this. So Azure Backup, in this case, it can help you to back up a VM. It can also help back up any VMs, including Linux or Windows. Not only so, you can also use Azure Backup to back up files, folders at your choice. It can also back up SharePoint server, Exchange server, and all that. So all at your choice. You need to know what's your purpose, what's your goal of your application, and then choose accordingly. Now, I also want to mention that beyond doing Azure Backup with your cloud application, it also supports on-prem backup to the cloud, as well as using Azure Backup as a tape replacement with your other applications. So this is a very powerful tool. You need to choose according to what you want to achieve. Now back to Mark.
Okay, thank you, Hung Fei. So let's continue our story. All right, we have a single VM. We decide that, all right, these services are good. We're going to deploy this now, and we're going to move this to the cloud. And as you can see, like I told you before, the back-end components are in the Microsoft Azure. The Akamai is sitting in an edge cloud in this situation. And the first thing I'm going to look at for resiliency, because we'll come back to traffic manager, we already talked a little bit about that, is my stateless VMs, my business logic. All right, I got to make sure that besides the scale out, what are we doing to make sure that these are always up and running, regardless of updatable changes that you make to the application or changes for maintenance, etc. So what can we do for resiliency? We have a couple things. We have availability sets, and we have something new that we announced this week called VM scale sets. And I'm going to ask Agal to come explain these to you.
Thank you, Mark. So the goal of availability sets is to keep your application constantly up. There are multiple scenarios which might cause your application to go down. The easy one to grasp is hardware failure. There could be failing hardware that will bring down one or more of your VMs. This is just fact of life. Hardware fails, it has MTBF, it fails. Another reason could be rolling update. You could be willing to update your application, sometimes daily, sometimes multiple times a day, and you want to make sure that your customers don't know about it. They only get the value from it, they don't see the downtime potentially associated with your update. So availability sets are targeted explicitly to solve explicitly this problem. So in the example here, we have front-end and business logic tier separately. When we define availability sets, we want to make sure that we define the failure domains or failure configuration based on each application tier separately. In the web front tier, we see software load balancer that we need to configure. And this software load balancer will select which VM will accept the customer traffic. We will create a set of VMs behind the load balancer. Those could be VMs of different size. It depends on the application needs. And eventually, we'll have high availability. When one VM will go down, the load balancer will send the traffic to another VM. Very similar thing in the business logic tier. We could have load balancer there. We could have some queuing mechanism where VMs get their work. But bottom line is that all the VMs are working in a unison. So if one VM is down, other VMs can pick up the processing job, can give the customer value. So let's take a look at how this works. So in this example that you see right now, we have 3 server racks. And our VMs are going to be assigned to different fault domains. In this example, we assume that we have configured 3 fault domains, which is default. For 3 VMs with 3 fault domains, availability sets will automatically put them on a separate machines, on a separate pieces of infrastructure. No hardware is shared between those VMs, between those, fault domains. So we can be sure that if fault domain 0 for some reason is down due to some hardware failure, other fault domains are still up and they are not impacted by that hardware failure. So in this case, there was a server that was used to host fault domain 1 for web frontend. It could also be the case that fault domain for business logic is hosted there as well. It could be that it's hosted somewhere else. They don't have to match. Each availability set is mapped separately. But in this example, I'm showing that they are matching. They are, in fact, running on the same piece of hardware, and they went down together. Infrastructure will go, first of all, and try to allocate those VMs on the different machines, and within minutes, we'll get them back up. But during that time, until they're up again, you want your application to be up. An availability set with load balancer will make sure that this happens. And here they're fixed, all good. Another example is update. Think about rolling update. You want to define a concept. We have defined a concept, and you want to use it, which is called update domains. Update domains allow us to limit the scope of the update to specific VMs. By default, you have 5 update domains, but you can, of course, configure that when you create availability set. And when you perform your update or we perform infrastructure update, we make sure that only one update domain is impacted at a time. So let's assume there is an update going on. Update domain 0 currently is impacted. It will follow with update domain 1, and afterwards update domain 2. Eventually, we will be done. We had rolling update. The service didn't go down because when one of the VMs or some VMs were down, load balancer was able to redirect the traffic to the VMs which are still up. So throughout the presentation, we have the sign useful tips. Those are the takeaways you can use later when configuring your service, kind of summarizing the important points. So just a couple of points. First one is you probably want to have 2 or 3 fault domains in your application to make sure that availability is not impacted when unexpected things happen. And they will happen. When you add a VM to availability set or when you configure an availability set, we will automatically put it in the right update domain and fault domain so that the VMs are distributed across fault domains and update domains. However, when you delete a VM, you decide which VM to delete. So after deleting multiple VMs, you might end up with a configuration where all your VMs are in one fault domain or in one update domain. You probably don't want to be in that situation. So control over deletion of the VMs and high availability during the deletion is on you. So make sure that you delete the right VMs when you delete them. Let me share with you some exciting announcement about that we are essentially GAing, putting to general availability here in build, virtual machine scale sets. From the availability perspective, this is availability simplified. We just went through experience of configuring availability set. Let's walk through the same experience with scale set. First of all, we define a VM. We identify an image that we will use for our VM. When we define scale set, what infrastructure does for you, it uses this image to set up multiple VMs, auto-configures pre-integrated the load balancer, and eventually you also are getting auto-scale out of the box. So the only thing you need to be aware of is count of machines you want to have. That's it. All the rest is on us, and we'll make sure that it's still running in the highly available configuration. Select an image, assuming those are the same machines, same VMs, and we'll scale it up or scale it down. Honestly, the only thing that it asks for you in the portal is select the count of machines you want to have. Select the image, and you are done. So Azure outsources at least some of the complexity from the scale sets. Let me get the mic to Hongfei to demonstrate how availability sets work, just kind of experience. Does it really work, Hongfei?
Thank you, Yigal. So here in this demo, I'm going to walk you through how to create a simple website that is backed up by 2 VMs. So if one VM is done, my website is still available to my customers. So as you can see in the screen, here, my simple web page just shows which server, which VM served the request. I have 2 VMs, 0 and 1. Right now, VM 0 was serving the request. And I'll just quickly shut down one VM. OK, stop it. So at this point, my VM is shutting down. I don't want my customers to see the difference that one VM is not available, right? So how I did this is I didn't start from scratch for this demo. I searched for template. We have many, many great templates, either from the Azure portal with certified templates or from the GitHub with community-contributed template. You can find a template that's close to your need and just twist it, then deploy the template to create something. So here, I have a template in my small script. It just did something very simple. I just deployed a template with to my resource group, and it created the website I just mentioned to you about. So let me show you the template, and my 2 VM is in an availability set. That's why it gives the availability when one is done. So let me show you how the template looks like. So here, the template is long, but I want to focus only at the section where you see availability set. We just simply have a loop and put those 2 VMs into the set. That's it. And what you get from your availability group, from your portal, you can see things like this. So here, I have my demo availability group. As Yigal said, I need to have multiple update domains and multiple fault domains. In this example, I have 3 fault domains and 5 update domains, and 2 VM was put into this availability set. As you can see here on my screen, those 2 VMs are automatically put into different fault domain and different update domain. This isolates them from hardware failure as well as software upgrade order failure, right? So now let's come back to my application. remember, I already shut down one of the servers, right? So my customer come, they still want to continue shopping. Oops. My other server, is it also done? One is done, the other one is running. Interesting. As I said, bad things do happen. So as you can see, server 0 is on. Did I shut down the wrong one? I know why. I haven't refreshed my screen. Something is not consistent on my screen. So let me go back and refresh and to figure out what's going on here. So I go to my resource group. And I go to my build demo. And from there, I look at my availability set. You see here, accidentally, from my last practice, I shut down another VM. So neither of them was available. That was the reason. If one is on, I'll start one now and come back to this one later. You'll see our website will remain working. So use more than 2 VMs. Somebody will shut it down accidentally. Now, go back to the presentation, Mark.
Thank you, Hongfei. So we are covering technology resiliency, and I have to work on the human resiliency next. So let's continue our story. We talked about the single VM, the dev test VM. We talked about stateless VMs. Now let's move to the state side of the house, the data, the storage. And let's start looking down here. My Elasticsearch and Grafana, in this case, does dump to Azure Telemetry. Is also dumped to Azure Tables in this case. And so how are we going to keep this resilient? Well, there's a couple options we have. Local redundant storage, which is available today, and then, of course, global redundant, geo redundant storage as well. Let me just quickly cover both of these. So you can see here in my picture, I have a Azure table, and I set up my local redundant storage as a replicator, basically copy on write technology, and writes a copy to my, my secondary. In this case, it is synchronous. All you have to do is turn this on. It is synchronous, and that means it's transparent to your application. There's 3 copies, in case Hongfei deletes one. I'm kidding, Hongfei. There's 3 copies, and you don't have to do anything in order to fail over. Now, there's a latency, obviously, if you turn it on, but outside of that, this is like a no-brainer for us as we turn on local redundant storage. So that's one of the options. But you might want disaster recovery. So in that case, what you would do is you'll go to a different region, and in that case, you'll set up geo-redundant storage, and basically it's the same thing. You just basically turn it on, specifying the other site, the other table, and the other region, and off you go. Now, there are some differences here. Obviously, if you're going to go to another region, you probably don't want asynchronous. You probably don't want to wait for that. So it is, by default, asynchronous to the other copy. And since it's asynchronous, it's also not transparent in your application. So you need to use the client SDK, and we provide guidance on this. You can actually do a couple of different things. It could be an active-passive situation where you just go after it when you know you're down, or it can be read-write for your local and read on your remote site. You can do that. And there's guidance already on our website to show you how to do that. So it can be a read-write and a read. And again, you can fail over right within your application. So those are local redundant store and geo redundant store. Why don't, instead of talking about it, why don't we show them something, okay?
Yeah, sure. So you have your shopping cart on, right? And you store some information in the backend. And when the website is done, when a storage account is done, you want your application still be available in some way. Perhaps not fully, but perhaps people still should be able to browse the category and continue shopping, right? So in this simple demo, I have a simple application. It's read-only. It doesn't write, right? I'm cheating with a simple application. So with this read-only, though, I have a storage account. And what I want to show you is I want my application to be resilient against the storage failure. So I just run through this application once, and it reads from a blob storage, right? And here on the screen, I have a fiddler. I will show you a little bit later. It shows you which storage account it's reading from. So now let me start my little fault simulation. So in this file, it's the host file. Here, we're showing on the screen. Where did it go? Daytime. Let's go back to Mark. You talk about the SQL first. I'll fix this one.
Okay.
Another mistake.
No problem. Thank you, and we'll come right back to that because that's a pretty cool demo. All right. So now, let's continue our story. We now covered Singo, we covered stateless, we covered Azure Storage and State. Now let's move to the tougher part, the back-end database. So in this case, they chose to run in a VM because that's what they had on-premise. They thought that was easier, albeit I'll talk about later how they have converted this to an Azure SQL DB instead, and we'll talk about why. But in this case, it's an Azure SQL VM. And they turned on a product that's been shipping for years called SQL Always On. And in SQL Always On, basically you have a primary, and then you can have up to 8 secondaries. And the secondaries can be a combination of synchronous and asynchronous. So in this case, being local, it's probably a synchronous copy, but it can be either one. You get to specify what it is. Each of the copies can be set to read-only as well. As a matter of fact, even the newest features, you could have multiple copies. You could put a load balancer in front of them and actually have a scale-out read-only option with that. You can see this in this case, I'm saying in the same region, but just like the geo-redundant storage, I can, for disaster recovery, I can send this to a different region. Matter of fact, since I have multiple copies, I can send it to regions across the world for local, faster read access to this. All right? Now, obviously, you can set it up synchronous as you want. You do have a choice here, but obviously we'll recommend asynchronous if you're going across regions so you don't have to pay for that latency. So what happens in a failure? This is all built in now. You don't have to build this into your application. But what we're going to do is we're going to, first of all, if a SQL goes down and we can't get to that SQL server, we actually have a witness because you need a quorum. You need to understand, just in case my second one can't hit my first one, maybe it's a network. Maybe my first one's up and running. So with a quorum, the witness and the secondary determine, hey, I can't get to that primary. We agree together, we're going to fail over to the secondary and make that my primary. So that's done all built into the software when you deploy SQL Server Always On. All right? Now, there are some differences between this, and let me just run over here. There are some differences between this and Always On premise, a couple differences, and that's all documented in a blog for you. So that second blog down bottom, you want to go there and read that differences. The Azure SQL Cat team wrote that up. And the first one, there is also a step-by-step guidance that I'd like to take you through. And out here, I recommend you walk through the guidance to set this up.
Put this up.
Oh, do I have to? It's not showing? Oh, I think, so anyway, I am looking at guidance that you can't see. It's really cool. All right, so, all right, and we'll go back to that. All right, there is a step-by-step on the first link that you can go to, and we recommend that you follow that guidance. Part of that guidance is going to tell you that the same availability set that Agal talked about earlier, you want to put your databases in there as well. Because if an update's going to happen between those databases and the witness, And you're in the same update domain, they all may get updated at once. So you put them all into the same availability set, therefore you get the same high availability that Igal was talking about earlier. Okay, so that's SQL Server and state. Are you all set? You
Yes.
ready? Okay.
Ready.
Let's
So,
go.
As you can see,
videotape.
no matter how well you practice, right, you can spend all day, all long to prepare for disaster. And you would think nothing would happen because you're so prepared. But it happens. And it happens again and again. All right, so this is the host file. Those two lines were together. So what I do here is I just added this host file to point my primary storage account to a local host. So this is like inject some fault into the system. So my my app would not be able to reach the primary account. All right. So with this one, I go back to my demo setting. With this, so I will show you in my application, I have a storage account set up, enabled that secondary read-only geo-redundant storage, right? So in my application, I simply use the storage API to do retry logic. So let's take a look here. Here on my screen, you see, I just choose the read mode to be primary, then secondary. There's different mode you can choose from. You can choose either just read from primary, read from secondary, primary, then secondary, or secondary, then primary, right? Then that's it. From now on, the logic behind the which storage account is used, that is transparent to my application. However, you need to know geo-redundant replication is asynchronous for obvious reason, performance, right? You don't want to have performance penalty because you're doing replication. However, that causes one side effect. Your two storage accounts might not be consistent at the moment you read it. So again, this goes back to application logic. You know about the tolerance of your application, right? Then you need to design accordingly how you handle those type of inconsistency. So here, in my little read application, I just continue to run it and to read it from the storage. From the local host, you see, I already cannot reach my storage account, the primary account. So I'll keep reading. And so what I want to achieve is by reading from this one, if you look at my fiddler, right, it tells me which storage account I was reading from. Let me see. So my two storage accounts have the same name, except that the second one have secondary appended to it. Surely enough, you can see from my fiddler, here, many read as I execute my program came now from secondary, right? So this is how using the storage redundant application feature could help your app to be more resilient with read-only assessment. And if you have other need, if you want write also to be resilient, there's more work you need to do. But being able to read from the secondary offers an option for you to do more work, such that if write is also critical to your application, then you can make it work, even your primary storage is done. All right, goes back to Mark. Thank you.
So again, I left you a few tips. The one down bottom, it says consider using Azure SQL DB, which is exactly what this online retailer has converted to recently, because the replication, the geo-replication with Azure SQL DB was easy to set up and manage and fail over to. So that's the third tip that we left you with. Okay, we went through our application as far as to build it and deploy it and the pieces that we need to make resilient. There is one last tip I have for you before we turn it over to a very important part called maintenance. And that is, what regions do you choose? And is that important? Well, we have something called Azure Paired Regions. This is all documented. The link down bottom will show you the site. Keep an eye on this because we add 4 or 5 regions per year. So keep an eye on the paired regions. It gives you a couple things. Obviously, it gives you the disaster recovery because it's another region with hardware. But it also gives you software isolation as well. So think about that. You have both regions. You have the software isolation. So if you have to update your application, you have the secondary site with the software separated that you can actually fail over to as well. Handles for updates, handles for failovers, things like that. So you have both within the paired regions. And we'll talk a little bit more about paired regions when we get to maintenance, which is next. We build it, we deploy it, and now, just as importantly, we have to maintain it. So, Agal, take us through.
Thank you. So there is a set of things we need to make sure that we do in order to keep our availability high through the life cycle of the application, through the life cycle of the service. Assume we deployed it in high availability. Assume it's all working as expected, we prepared for the scenarios. We still want to make sure that we have enough diagnostics, enough health data we can debug in case this needs to happen, in case we need more data. We want to make sure that we are prepared for application updates and we can run those consistently daily or multiple times a day. Hardware failures will happen. Not question if will happen. This is the nature of hardware. And there's one little thing that some of you might know, host updates or planned maintenance that might also cause downtime. So my goal in the next minutes is to show you how we can avoid impact on your application from all those operations. So let me start first with the cool feature that we released some time ago, memory preserving update, and it's really cool. The idea is to avoid rebooting customer applications when we want to update the underlying hypervisor layer in the host. We continuously, of course, keep our servers secure and perform security updates, but our goal is to make sure that the application doesn't know about it. And when I say don't know about it, I mean it doesn't slow down, it doesn't start behaving weirdly on some API calls, but the idea is it's really consistently performing through its life cycle, and only specific time-limited impact is detected. So from our perspective, we are limiting the impact to in most of the cases, to 9 seconds, in some cases to 30 seconds. But the idea is, from the application perspective, VM just continues running, keeps the state. In some point of time, we freeze it, and during that freeze, we perform the quick maintenance of the hypervisor underneath, of the infrastructure underneath. When we resume it, your application should not know about it. In case of 9 seconds, TCP retransmit will take care of it, and it just looks like a clock skew. Most of the application will be completely transparent to it. In 30 seconds case, most of the retries, most of the applications will still retry and make it work. It might look like a glitch in the network, but not beyond that. The impact is limited to those seconds. There's no slowdown before, there's no slowdown after. After those 30 seconds, you get all the capacity, all the performance you paid for. So let's just go through this cycle and have a feeling how it works. We start from getting VMs to sleep. We quickly update the hypervisor underneath, or the infrastructure underneath. I call it for simplicity hypervisor. There's, in fact, much more infrastructure there. We quickly get it back up, and we quickly get VMs back up. So I think it took me more time to talk about it than for this operation to actually happen. And once again, it happens on scale. We are very focused on keeping the impact not beyond that number, and we are performing our updates in such a way that should be transparent to your application. However, I have to be honest with you, once a year, we need to do a bigger maintenance, and this maintenance might require us rebooting your VM. And despite the fact it's just once a year, we of course want to make sure that your application is up during that once a year time. By the way, that once a year improvement, that's a new functionality. With memory preserving updates, we were able to move to a point where we can actually promise that it's only once a year, not beyond that. And all our urgent updates are actually happen in a transparent way. It's also new, by the way, so it's cool. So one option that we are rolling out for private preview before the next planned maintenance is maintenance redeploy. The idea is to allow you to select a window for your application to update. This is going to going to be essentially an update, but within your control, within the control of your VM. You decide which window will work for you, and you can perform the planned maintenance in that window. By the way, if you don't want to do anything, we'll just do it on the weekend and update infrastructure during one of the weekends with at least a week of notice in advance by email, making sure that you guys know about what we're planning to do. One last thing I wanted to mention about this, and that's actually the coolest thing, I think, is in-VM notification. Before we do anything to your VM, we'll try to tell you within the VM that the reboot is pending. And there are two reasons that might be causing this reboot. One reason is planned maintenance. We just talked about it once a year. You might want still to create safe shutdown for your VM. You might want to respond to the reboot request by syncing your database or syncing your state and potentially removing VM from the load balanced set and shutting down it by yourself so that no data corruption occurs, no data loss occurs, and customer experience is just perfect. But there's also another reason. We are adding functionality to predict hardware failures. We have enough hardware and we have enough machine learning resources to be able actually to correlate and predict. So in some cases, we will be able to predict the hardware failure before it actually occurs and give you some minutes to shut down your VM safely before it starts on a different piece of hardware. So with the same notification, you might see your VM going down or going through the maintenance event due to the fact that specific physical machine that you are running on showing enough signs that we are pretty sure that it's going to go down in the next minutes or hours. Once again, our goal is to be better than hardware, predict that, and give you the ability to control your fate, to safely shut down in this case as well. Once again, not all the hardware failures can be caught, but there is a significant amount of hardware failures that we can predict. Let's take a look at the sample. Let's take a look at the sample, yes. So you can see here an API that you can pull from within the VM. By the way, this is still in preview. This feature is still in preview, and but you can already use it. You can go to that API and query it. Normal result, you get nothing, you get empty data. In some cases, you are going to get the event ID and event creation time, and from that point on, you'll have 5 minutes to respond. So essentially, you can pull this every half a minute or every minute and have enough time to respond to a potential downtime. So the samples that I brought here, scheduled polling script. If you run this sample every minute, you can essentially just create an error message in the event log telling about the potential downtime that is coming to that VM. So this is PowerShell example, but of course you can do the same thing in Linux or elsewhere. We have actually a pretty good sample in our blogs that shows you a couple of usages. But bottom line, you can code it, you can prepare for it in advance, and the most important, make sure that customers don't have an impact. By the way, if you guys are using PaaS, platform as a service, and running your software as PaaS, very similar event occurs through role entry point on stop method. So essentially, you can subscribe to that method, and you'll have also 5 minutes to respond before we take your machine down. You can essentially delay the processing or delay the completion of this function until your VM is ready, and only then we will continue with shutting down your VM. So role entry point on stop, also there in PaaS today. So one another scenario I wanted to share with you for graceful shutdown, and this is a little bit more complicated, but I hope I can convey it in this forum. Think about one VM going through this situation. What we want to make sure is that customers don't know about it. So the proposal here is to take this VM out of load balancer set, configure load balancer to use VM2 and up to VMN, take the VM1 out, do the stuff that has to be done with it, and when it comes back up, add it back to the load balancer set. So very small sample here is, and once again, it can be done in multiple ways. You could create a custom probe for that VM. There are multiple things you can do. For the simplicity, I added here just a configuration of removing Azure endpoint. Once again, you could think about configuring a load balancer in a different way. But the idea is when you detect that this event, there is an event pending, you go to configuration of your service and remove Azure endpoint for this VM, specific VM from your load balanced set. Customers that are connecting to you will be just redirected to another VMs. Your backend data layer is consistent. Nothing is lost within the state because you can save, you can add in the same if condition some another logic to sync your state, and you are all good. Isn't that exciting? Thank you.
Woo.
So, last point I wanted to mention, it's clear that eventually we do want to make sure that our VMs are still running as expected. I want to give you a couple of pointers for debugging that or for understanding the health state of your VM. So first of all, there is audit log history per VM. You can go and query which changes in configuration you did to your VM and what we did to your VM. So all of those are available in audit logs per VM. I added a link here. You can click that link in order to take a look at the code samples of how you access this programmatically. You can also do some processing on it. And I also show on the right side here the actual UI. I got inside the VM configuration in the portal, and you can see that there was one informational event that occurred for that VM, write extension, some 3 weeks ago. So either through UI or through code sample is in the link. You can check a health for that VM, which is just below audit log section in the screenshot. So check health will give you the current state of the VM. It will try to estimate what's going on with your VM right now. I have some problem with the VM. I don't know what's going on, but I want to know what the platform thinks that my VM is fine or not. Is there something happening on the platform? Is there something happening on the internet that blocks your connectivity? Something that interferes with normal execution of your VM. Or maybe you're just updating your code, going through something that keeps this VM down. So check health will get you this information real time. We exposed it. We are GAing the check health actually also in build. And we will continue improving it with more and more checks, more and more validations for each VM. But the idea is simple. Tell me right now what's going on with my VM, and it goes, looks for the stuff, troubleshoot stuff, gives you some kind of estimations. Important thing, it gives you that estimation in place. In case you didn't use boot diagnostics, this is also pretty cool. You can see the boot screen of your Windows VM with the date. Make sure that your VM is up. Did it start or didn't it start? In some cases, there could be, some common things that could happen. You could have problem with starting up your VM due to drivers or due to registry corruption. You could see the actual screenshot from what's going right now with that VM. If you are using Linux, you can see the serial output of your VM. So you can just access all the serial outputted log. We will show it in the portal. You can just look at the messages, all the messages, make sure that that's what you expected. Bottom line, you can understand whether your VM has booted correctly, and it doesn't, or you can rule out whether it didn't boot because it didn't start correctly. Last point I wanted to convey is redeploy button, also new for the build. So the redeploy button allows you to scratch it all. I don't know what's going on there, scratch it, start it elsewhere, start it again elsewhere. So from one perspective, you scratch all your state and you start your VM elsewhere. There might be something happening with your VM. You don't know, you couldn't debug it, just start it elsewhere. Take my image, start it elsewhere. Or you suspect there's something with the platform, which of course shouldn't happen, should never ever happen. But this button will also give you to another location. So everything about your VM is scratched, and we are just setting it up elsewhere so you can start from a clean sheet. Hopefully you don't need to use it, but there are cases when VM can get stuck. You cannot control it, it's not fast enough. You can just click this button and we'll just scratch it and start it again. So redeploy in the portal, go to the VM blade, and in the VM properties you can see the redeploy. And with this, I'll get Mark back on stage.
Okay, I think Hung Fei wants to show you something now.
Yes, dear customers, I'm glad to report to you Our life site now is mitigated. Your shopping cart continues to work now. It was down for 10 minutes, and we did an RCA. Unfortunately, we had 2 copies, and both was accidentally. One was intentionally shut down for maintenance. The other one, somebody else, the idiot, was shut it down. So, lesson learned. For higher resiliency, you need more than 2 copies. The more copies you have, the more resilient you are. Nothing comes for free. No, comes back to Mark.
Okay. Thank you, Hongfei. Thank you. So the story now coming to a close. Our online retailer is in production. The sales were actually considerably higher than they anticipated, but fortunately, in an elastic scale environment, they could handle the scale. They are 100% uptime. They are updating the system constantly based off responses from their customers, but they can do that because they are software resilient. They set it up that way. And what we covered today was we covered from the journey that they took. They used a combination of platform as a service and infrastructure as a service. They implemented technologies like availability sets. They're doing backups. They're using SQL always on. And they continue. And we're 100% confident that we're going to be able to handle that 15 to 20% workload come this upcoming Thanksgiving. So very confident with that. Really, I kind of lied to you. The story really is not ending. Constantly trying to make things better. So they are implementing, as I mentioned, they are moving away from SQL VMs. They're moving to Azure SQL DB. And the business logic, they're actually seriously considering and piloting moving to a platform as a service as well with the Power Logic stuff that you saw this week coming out of that team. So we continue. But they are resilient. They think about resiliency every day, and they can do it on the Azure platform. So what do we leave you with? We leave you with your application will go down. Doesn't sound very good, but think about it. Aren't you going to update it? Sure, you're going to update it. You ever have hardware failure? It's going to happen. Is Agal going to come through and do that maintenance once a year? Probably. So your application...
I'll try not to.
Not his fault. Yes, it is. Yes, it is. It's his fault. All right? But, so it's going to happen. So what I leave you with is this. And that is, what will be the experience of your customer? So thank you very, very much. You guys are awesome to spend the last day, last session with us. As 3 copies, we will scale out. And we will maximize throughput of Q&A if you want to come up after the session. Thank you very much, everybody, for attending.
Thank you.
Thank you.